Hi there, grade 10s. I've just prepared a worksheet for you containing a whole bunch of algebra revision that you would have covered in grade 9. My suggestion to you is for me to read the question, for you to pause the video, attempt the question, and then afterwards you're welcome to play the video and see how you did. All these questions will pretty much cover your syllabus that you did in grade 9 with regards to algebra. So there's going to be a taste of everything. Right, the first question, 1.1, asks you to determine the value of this expression, 2x cubed minus 3x squared plus 9x plus 2, if x's value is negative 2. Now, this section you would have covered early on in grade 9, and it talks about substituting this x value into this expression. And the way I like to do it, and I'm sure your teachers will do the same, is we use brackets to replace the x value with what its value is. Right? So you see wherever there was an x, I've put a bracket. So this means 2 times something to the power cubed, or to power 3, minus 3 times something squared plus 9 times something plus 2. So these brackets are reserved for the negative 2's. Right, so we've substituted the value in. There are now no more x's or variables in this question, and now it's a case of just multiplying it out. This cube over there applies only to the negative 2. This 2 is going to be multiplied by what this negative 2 cubed gives you. So I'm going to leave the 2 for a second here. Negative 2 cubed means negative 2 times negative 2 times negative 2, which a negative times another negative is negative, and you're going to have that being negative 8. Okay, check on your calculator if you're not too certain, but yeah, you should hopefully not need a calculator for that. Negative 3 now gets multiplied by what negative 2 squared gives you. What is negative 2 squared? Negative 2 times negative 2, which is positive 4, because a negative times a negative is a positive. 9 times negative 2 is negative 18, and this plus 2 is just hanging at the end. Next step, 2 times negative 8 is negative 16. Negative 3 times 4 is negative 12. We've got our minus 18, and we've got our plus 2. If you're not too sure now in terms of working that out, you're welcome to use your calculator, but let's try to do it in our heads. Negative 16 minus another 12 is negative 28, right? Negative 28. Negative 28 subtract a further 18 will give you negative 46. You're becoming more negative. And negative 46 plus 2 is going to give you your final answer of negative 44. Okay, use your calculator to guide you if you're a bit nervous, but you have to show your calculations. Right, moving on to 1.2, the question uses some English words here. Multiply that expression by that. Right, so we're going to now get rid of the word multiply and by, and we're going to create ourselves a maths sum here. So if that there is being times by that, we can write it as follows. Watch. 4ab must be multiplied by 5a squared b squared plus 2ab minus 3. Do you see that? There's a little dot there, or a multiplication sign, and that is being times by this whole expression. Now, the distributive law tells you that this 4ab must be multiplied into that term, multiplied into that middle term, and multiplied into the negative 3. Okay, let's do that. 4ab times 5a squared b squared is going to give you what? The 4 times the 5 gives you 20. The a times the a squared is going to give you a cubed. And the b times the b squared is going to give you b cubed. Happy? The 4ab times positive 2ab will give you positive 8a squared b squared. Agree? And lastly, the 4ab times negative 3 will be negative 12ab. Why negative? Because a positive 4 times a negative 3 is negative 12. We now must decide, can I join these 1, 2, 3 terms together? And the answer is no. We stop there because those are unlike terms and they cannot be joined together. Right. we move on to 1.3.1, which has the heading, in fact, all of 1.3s have the heading to simplify. Now, the instruction to simplify means to make this thing simpler. And a lot of the time, it means to get rid of the brackets. Right. So this, you'd notice, is one term. A squared b cubed is all being squared, and a times b squared is stuck at the end. So the first step is to get rid of this bracket. Now that 2 is going to get times into this bracket. In other words, this exponent, a to the power 2, is going to be affected by that 2. This b cubed is going to be affected by that 2. And the way you could write this out is to say that 2, and you don't have to do this, I'm just trying to explain here, that 2 means that there are actually 2 of those brackets. Do you agree? It means that you could write out that bracket twice. And it's a nice way to maybe think through a question. Now, if I want to make this whole thing simpler, let's look at all the a's. I've got an a squared there, I've got an a squared there, and I've got an a over there. So how many a's are being multiplied all together? You've got a squared, a. That a, by the way, has got a little 1 up there, by the way. We don't really need to write it. But a squared and an a squared and an a will give you a to the power of 5. There are 5 a's being multiplied all together. And in the same way, b cubed, b squared, how many b's are there? There's 3, 6, 7, 8. So your final answer will be a to the power 5 times b to the power 8. 1.3.2 now involves fractions. But it's important to note that these fractions are being separated by a times sign. So this whole sum is actually only one term. If you recall from back in the day, primary school, let's say, if you had, let's say, 1 over 2 times 8 over 10. If you wanted to simplify that, you could cancel this 2. 2 goes into itself once, and 2 goes into 8 4 times. That process of cancelling across a multiplication sign will also be allowed over here, except we don't have numbers, we've got variables. So you'd firstly notice that I could put that in brackets. I'm basically saying that that numerator is one piece together. That denominator is one piece. I'm going to treat it as a one solo item. Now that there's a times sign, I can cancel that x minus y with that x minus y, just like I cancelled the 2 with the 8, right? Y plus x is indeed the same as x plus y. Do you agree? 1 plus 2 is the same as 2 plus 1. So this can also cancel with not this whole piece. This x plus y all squared actually means x plus y times another x plus y. So when I cancel this denominator, I'm cancelling this 2 down to a 1. There is now only one x plus y remaining. This here is left with a 1. So 1 times, and let's do this, I'll show you, 1 over 1 if you like, 1 over 1 times, what did we say was left over here? X plus y was left. And now that I've cancelled the denominator, does it mean that there's a naught at the bottom? No, it means that there's a 1. Now, do you really think we need to write 1 over 1 times x plus y over 1? No, our final answer is simply what? X plus y. Happy? Right, 1.3.3 is a little bit more difficult. I'm going to go through it slowly with you. It involves exponents, and the ugly thing about these exponents is that a lot of them are negative. Right, so let's try not overcomplicate it, and I'll show you the quickest way to work through a sum like this. By the way, only one term. That whole expression is only one term because it's not separated by a plus. That's a multiplier. First of all, 3 times 24. What is 3 times 24? It is 72. Now, a to the power negative 2 times a to the power negative 1. When the bases are the same, they're both a's, and we are multiplying them together, we simply add the exponents. As an example, if I had to tell you this, x squared times x to the 5, let's say. What's the answer? When the bases are the same and we multiply, we simply add the exponents, giving us x to the power 7, right? If I had to tell you x to the power negative 2 times x to the power 5, are the bases the same? Yes. So when the base is the same and we are timesing, we add the exponents. So x to the power negative 2 plus 5 is 3. So that process is what we are going to be doing now. A to the power negative 2 times a to the power negative 1. When the bases are the same, we add the exponents. Negative 2 plus negative 1 is negative 3. So I've successfully joined that a with that a to give us a to the power negative 3. In the same way, b, and that's b to the power 1, do you agree? B to the power 1 times b to the power negative 1 will be b to the power of, when the base is the same and we are multiplying, add the exponents. What's 1 plus negative 1? 0, right? And we're going to talk to that in the next step. At the denominator, I'm just going to write it out again. 9, a to the negative 4, b to the negative 3. Okay, so already it looks quite a bit simpler than what we've been dealing with. Now, the next step, let's look carefully. First of all, the 72 over 9 is a bit easier to deal with. 72 divided by 9 is how much? 8. So now technically, the 9 has cancelled. 9's gone into itself once, and 9's gone into 72 8 times. So we could put a 1 at the bottom if we want. Now, there are many ways to deal with these a's to the power negative 3's. Okay, the one way to do it would be to say a to the negative 3 when we do not like, or we don't ever like, negative exponents. So this a to the power negative 3, we send to the bottom, and it becomes a to the power of 3. In the same way, this a to the power negative 4 at the bottom, we don't like negative exponents. So the way to get rid of that negative exponent is to send it to the top, and it becomes a to the power 4. B to the power 0 at the top, anything to the power 0 is 1. So that b to the power 0 almost disappears, and it becomes times 1, which isn't really doing anything, hey? This b to the power negative 3 at the bottom, we don't like negative exponents, so we can send that b to the power negative 3 to the top, and it becomes b to the power 3. Does that make sense? Okay, I'll just digress for a second here. If I had to give you a divide question, watch here. X to the power 5 over x to the power 2. What would my answer have been? That x squared would have cancelled, making this x5 and x to the power 3. Do you agree? In other words, when the bases are the same and you are dividing, you subtract. So I could have said that is x to the power of 5 minus 2. I'm subtracting because the bases were the same when I was dividing. Almost the opposite here. When we are timesing, we add. 2 plus 5 is 7. When we're dividing, we subtract. And you would have seen that x to the power 5 minus 2 is indeed x to the power 3. So where I'm going with this little logic here is if I had x to the power 2 over x to the power 5, right, what are we doing? We could say that if I would cancel the x squared, leaving me with 1 at the top, and x to the 5 reduces down to x to the 3. Do you agree? But if I use my subtraction method, because the bases are the same, it would be x to the power, now let's subtract 2 minus 5, which is x to the power negative 3. So what I've basically just proven to you is that x to the power negative 3 is the same as 1 over x minus 3, right? And that's what we've just done over here. Look, a to the power negative 3, we didn't want it over here with a negative, so we sent it to the bottom, and it became 1, so there was still a 1 up at the top, over a to the power 3, just like this example over here. So we're not quite finished yet. We've got one more step to go. The 8 over here, nothing's going to happen to the 8 because he can't cancel with anything. However, this a to the 3 lies beneath an a to the 4. So a to the 3 gets cancelled out entirely, and a to the 4 gets reduced down to a to the 1. So a, 8, a to the power 1, I'm not going to write it. The 1, I'm not going to write it. And b cubed. And there is our final answer, 8ab cubed. Okay, so a slightly more difficult question. I'm sure you'll elaborate on questions like that in grade 10. Right, moving on to 1.3.4. Remember, we are asked here to simplify, and this question is a little bit different from the previous ones in that although they are fractions, they are separated by a minus sign. So there are now two terms. You'll see even in the next one, this is separated by a divide. But however, this is still one term because terms are separated by a plus or a minus. So when we are asked to simplify two fractions that are being subtracted or added, we have to find a lowest common denominator. So what denominator could both 2x and 3x go into? Right? What number could 2 and 3 both go into? 6. And what variable could x and x both go into? They could both go into x. So the lowest common denominator we are going to select is 6x. Now I've made one big fraction because we are going to join these two fractions into one. So this denominator was 2x and we've now changed it to 6x. So how did it change? We multiplied it by 3. So if the denominator gets multiplied by 3, the numerator, which is x minus 2, must get multiplied by 3. In the same way, this denominator was 3x. What did we do to it to get to 6x? We multiplied it by 2. So in the same way, the numerator, which is currently x minus 3, must be times by 2. And that minus sign follows us. To simplify it, we now have to take the 3 and multiply it in to give us 3x minus 6. The minus 2 must get multiplied in to give us negative 2x and plus 6. Negative 2 times a negative 3 is a positive 6. Remember, our denominator is coming along for the journey. We can't get rid of that denominator. Now to simplify it another step, what is 3x minus 2x? Like terms, 3x minus 2x is 1x. And negative 6 plus 6 cancel each other out, 0. What's our denominator? 6x. So we've got 1x over 6x. Can we simplify that a little bit? What do you think? Yes, the x's can cancel each other out, and our answer will be 1 over 6. Happy? Great. Moving to 1.3.5, we've now got a question that involves division. Now, what do you remember about division? We're not really big fans of division, and the way we're going to follow these questions is we'll write out the first part and we'll change that divide into a times. Whenever we change a divide into a times, what happens? This here flips over and becomes 2a squared over 4x. Fantastic. Now it's similar to a question we did just now. We can now cancel across the divide sign, or if we want, we can cancel from top to bottom. But let's cancel, let's go. 4 can cancel with a 4. This x can cancel with that x squared to reduce it down just to an x, or an x to the power of 1. Do you agree? In the same way, that 2 can cancel with that 2, and that entire a squared can cancel with that entire a squared. So although it's a bit messy now, let's see what we have left. We have got left what? There is a 1, x to the power 1 over 1. So that whole term or piece over there is simply an x times what's left here. The whole thing's cancelled out, so it would be times 1. So do we really have to go x times 1? No. Our answer is simply x. Done. Right. Moving on to 1.3.6. And now we start talking a little bit about factorizing. Although this is still 1.3, so it's still simplifying, we are going to have to factorize before we can simplify. Now, the temptation that some of you might fall for is for you to cancel this x with one of those x's. Now, you can't do that because there is a minus and a plus. There's a binomial and a binomial. The only reason I could cancel away in the previous question was because there was a multiply or a multiplication. So we could cancel to our heart's content. Here, we're going to have to factorize first. So I'm going to probably mention these methods just now again, but when we factorize, we can use highest common factor, we can use difference of two squares, or we can use quadratic trinomial. Right. So what are we going to do at the numerator? Which of these three methods will apply to the numerator? Think about it. Highest common factor? No. Difference of two squares? Yes. The numerator is going to be a difference of two squares. So the process with difference of two squares is we're going to open up two brackets. X squared indicates that we're going to have an x and an x. The 1 means 1 times 1. Because what is 1 times 1? It's 1. And with difference of two squares, we have to have signs that are the opposite. One's a plus, one's a minus. Numerator done. At the denominator, we're also going to have to factorize. Which of our three methods are we going to use? The answer, highest common factor for the denominator. So what is the highest common factor? What goes into 3x as well as 3? And the answer, 3. So we take 3 out as an HCF and we open a bracket for what remains. If we've taken out a 3, what's left in 3x? The x. If we've taken out a 3 from the second part of the denominator, what is left? 1. And the sign is still a positive. Remember, if we had to multiply this back in, we would get 3 times x is 3x, and 3 times 1 is 3. So we've successfully HCF'd correctly. That looks a little bit more confusing, but watch what we are now going to do. We are going to be able to cancel. So this bracket of x plus 1 is going to cancel with the x plus 1 bracket over there. We now have got what? X minus 1 at the numerator over 3 at the denominator. And that is our final answer. We can't go any further. We are done. Right. Moving on to question 1.4. And here is where I mentioned factorizing is going to come into play. Right. What were those three types of factorizing? Can you recall? Highest common factor, difference of two squares, and quadratic trinomial. Right. So now, in 1.4.1, 1, 2, 3 terms. So straight away, difference of two squares, I'm going to rule that one out. What method can I use? Highest common factor or quadratic trinomial? And the answer is highest common factor. 1, 2, 3 terms all have got something in common. What number goes into all 3 terms? 3 goes into all 3. What variable goes into all 3? All 3 terms have got at least an a. Open a bracket. If I've taken out 3a, what remains over there? A squared. If I've taken out 3a from this term, what remains? 3 times something will get me back to 9. 3 times 3. And a times what will get me back to a squared? A. And if I've taken out 3a from negative 6a, what remains? Negative 3 times what will get me back to negative 6a? And the answer is negative 2. So I've successfully HCF'd. Now, although you'd be tempted to move on to the next question, we can actually do something more. This bracket is going to be a quadratic trinomial. That means that 3a is going to just sit there in the front, and we're going to form two brackets like that. A squared means that the start of each bracket is going to be an A and an A. We then look at the 2 and say, how do we get to 2? The answer being 2 times 1, the only option, in fact, to get 2. So 2 times 1 goes over there at the end of both brackets. We now have to look carefully at the signs. The signs over there, and in fact, I'm actually going to abort this mission here. And I'm going to tell you exactly why. The A squared over here is right, A times A. But watch carefully here. This is what I'm realizing. The negative 2, the negative sign means that the signs would have to be the same, right? That negative means negative and a negative. And that I would be very tempted to leave as my answer. But if we had to FOIL out that bracket, what is the L of FOIL going to give me? Negative 2 times negative 1 is positive 2. But our previous step had a negative 2. So I almost fell for it. You cannot quadratic trinomial. That there is your final answer. You'd have to know to stop there. I was tempted, but I caught myself just in time. Okay, so do not do quadratic trinomial. Stop there as your final answer. Right, 1.4.2 then presents a slightly more confusing question. However, it's important to notice that there are how many terms? There are 1, 2 terms. So, back to our 3 methods for factorizing, which method would you choose? 1, 2 terms, so definitely not quadratic trinomial, right? But I'm going to take out a highest common factor. HCF should always be your first one to consider. So, what is common amongst both terms? The bracket, A plus B. So if I take out an A plus B, what is left in this term? The 4. What is left in this term? Minus x squared. Right? So we've HCF'd first, but now, if you look carefully at this second bracket, we are going to be able to difference of 2 squares with that bracket. Difference of 2 squares. So this bracket A plus B is just going to sit and do nothing. And this bracket is going to become 2 brackets. And how do we know it's a difference of 2 squares? Because 4 is a square, x squared is a square number, and there's a minus, meaning difference. And there are 2 of them, so difference of 2 squares applies. Now for the first term in each of these brackets, it's going to be 2 times 2. Why? Because the square root of 4 is 2. What's the second piece of each bracket going to be? X squared. If I had to put x squared under a square root sign, in other words, what times what gives me x squared? X times x. And the signs with difference of 2 squares must always be opposite. One's a plus, one is a minus. Can I do anything else? No, I'm done. My final answer over there. Right, we move to the last section of the worksheet, which is 1.5, involving solving for x. In other words, what do we call these questions? Equations. Right, so for the first one, you'll notice that x is linear. There's only one answer that we're going to get over here. And the way we do this is we group all the x's on the one side of the equal sign and send all the constants to the other side. So if I choose to leave the 8x over there, I want this 3x to join the 8x. If I minus 3x away from the right-hand side to cancel and get rid of this 3x, I must minus 3x over there. Happy? So by removing 3x over there and getting rid of it on the right-hand side, I have to take 3x away from the left-hand side. What is on the right-hand side in terms of constants? Negative 22 is currently there. But I want this 3 to join it. So in order to get rid of this 3 on the left-hand side, I would minus it away. But if I minus 3 away from the left, I must also minus 3 away on the right. 8x minus 3x, how many x's? 5x. Negative 22 minus another 3. What is negative 22 minus another 3? Negative 25. And the last step, I want to get this x on its own. So this means 5 times x. So to get rid of this 5, I would have had to divide by 5. 5 divided by 5 would have cancelled the 5s. But if I divide by 5 on the left, I must say negative 25 divided by 5 on the right. Last step, final answer. What is negative 25 divided by 5? Negative times a positive is a negative. And 25 divided by 5 is 5. And there is our final answer. Remember, a way to check our answer is I could have taken that negative 5 and substituted it back into wherever I saw an x. Watch here. 8 times negative 5 plus 3 equals 3 times negative 5 minus 22. Let's see if the left-hand side equals the right-hand side. What is 8 times negative 5? What is 8 times negative 5? The answer, negative 40 plus 3 equals. What is 3 times negative 5? Negative 15 minus 22. What is negative 40 plus 3? Negative 37. What is negative 15 minus another 22? Negative 37. And please don't do this right next to your answer, but this is just a way to check your answer. And what do we notice? The left-hand side equals the right-hand side, so my answer must be correct. Right? 1.5.2 now involves a fraction. A fraction. So you've got x technically over 1 minus x minus 1 over 2 equals 3 over 1. You don't have to show those ones, but it's important to realize it when determining a lowest common denominator. Now, in determining a lowest common denominator, I look at all my denominators and I'm going to choose one that's common. What is common? 1, 2, 1. So all of them could go or have a denominator of LCD can be 2. So that means my left-hand side has to have a denominator of 2 and my right-hand side has to have a denominator of 2. So this one was multiplied by 2 to get to 2. So this x must be times by 2 to get to 2x. This 2 already had the denominator we were after. So x minus 1 does not need to change. However, this minus is applying to this whole term, meaning I have to put this x minus 1 in brackets when I move to this next step. Please don't forget that. This one over here was multiplied by 2 to get to 2, so 3 times 2 is 6. At this stage, listen carefully, I can drop the bases. I can get rid of the denominators. Because it's an equals here, it's an equation, I no longer need those 2's. So, 2x, I'm going to multiply the minus in. Minus x and plus 1 is equal to 6. Now this is much more easier. 2x minus x is 1x. I'm going to move that 1 to the other side. In other words, subtract 1 on both sides. And 6 minus 1 will leave my answer x equals 5. And there is my answer. Once again, you're welcome to substitute it back into the original question and see if your left-hand side equals your right-hand side. Last question, 1.5.3. Right, you will notice that this question is different in that the x, the unknown, the variable, lies in the exponent. That's why they call these questions exponential equations. Right, and the way that we work these questions out is we need to reduce the left-hand side and the right-hand side to have the same bases. So this base is 3, this base is 81. They're not the same. However, the 3 is pretty stuck. We can't change the 3. But 81 is the same as what? 3 to the power of what? 3 to the power of what? 3 to the power of 4. Now the left-hand side and the right-hand side both have the same bases. We now can drop the bases. We do not need the 3's anymore. And we can simply say that x plus 1 is equal to 4. Last step, I don't want the 1 there. I'm going to subtract the 1, making 4 minus 1, 3. And our final answer is x plus 3. Right, I hope that this revision worksheet on grade 9 algebra assists you and that you feel a little bit more confident going into grade 10. Good luck for the year ahead. I will post some more videos as the first term unfolds.